So in this unit we're going to study trigonometry, and in the past you've studied right triangle trigonometry and defined sine, cosine, and tangent. So if I have triangle ABC shown, I use large letters for the vertices of the triangle, and I typically use small letters for the length of the sides opposite a given vertex. So if I have angle A here at 90, side A is straight across from it here. Across from angle B is side B, and across from angle C is side C. And so if I want to talk about sine, cosine, or tangent, let's just take cosine and let's just pick an angle here. And we typically pick an angle that's not the right angle. So let's take angle C. And we know by definition that cosine is adjacent divided by hypotenuse. In this situation, adjacent would be B divided by A. The sine, let's stick with angle C, is by definition the opposite side divided by the hypotenuse, which from angle C would be C over hypotenuse A. And the tangent ratio is the opposite side divided by the adjacent side, which from angle C is C over B. Now what we want to do in this unit is extend our understanding of trigonometry to angles more than 90 degrees. And you might wonder, well, how is that possible when a right triangle can't have angles more than 90 degrees? Because if one angle is already 90 degrees, the other two together can't be more than that. So we're going to move beyond triangles to a coordinate system. And we're going to be able to draw an angle in an XY plane to measure any degrees, any number of degrees that we want. And we call that angles in standard position. So I have a grid, my XY plane here, and a standard position angle is measured in a certain way. We always start our angle from the positive part of the x-axis, which is here. I call that my initial arm, the initial part of the angle. And I can put my ending arm, my terminal arm, anywhere I wish. So if I put it here, okay, that'd be our terminal arm. We would measure the angle like so, the measure right in there. So I might have drawn an angle there of possibly 50 degrees. So let's say theta, in this case, is 50 degrees. If I measure my angle counterclockwise, the measure is a positive measure. So let's say that that angle I say is 50 degrees. Now I could measure the angle going the other way from, again, the starting point, the initial arm on the positive x-axis going around that way. If I measure my angle clockwise, then it's a negative measure. So this part here would have to be the remaining of the 360 from 50, so that would be a measure of, in this case, negative 310 degrees. So 50 degrees and negative 310 degrees terminate, have a terminal arm in the same place. Okay, let's draw a few more of these. This time I'm going to draw an angle in standard position that's 150 degrees. It's a positive measure, so I start at the positive x-axis. I go counterclockwise, so I'm up to about 90, and I need 60 more degrees. So this angle here, right here, from here to here, is 150 degrees. I could measure it clockwise. If I do that, then it would be measured at negative 210 degrees. Just to look at measurement of angles from another point of view, as I move the angle here, you'll notice that it's changing. So angle FOP, this angle here is 38 degrees, and I can go past 90, 150, so on. I can keep going to 200, 300 degrees. Okay. If I actually do that on this particular animation, then what's going to happen is it's going to measure the angle going back the other way. So it's measuring a negative angle here, from here to here, in this case negative 160. So by introducing standard position angles in a coordinate plane, we can define an angle to be any given measure, positive or negative, from 0 to 360 degrees and beyond. because when I go around another time, then we're just adding on from the 360. Another concept we want to talk about is a reference angle. So I'm going to start by drawing a standard position angle. Let's take 150 degrees once again, which is like so. Standard position 150 because it's measured from here. Now a reference angle is an acute angle, an angle less than 90 degrees, formed between the terminal arm and the closest part of the x-axis. So in this case, this angle in here, that would be called the reference angle. And because it's 150 degrees to the terminal arm, this little bit we can calculate to be 30. So we would say the reference angle of theta is 30 degrees. The reference angle is always a positive measure between 0 and 90 degrees. Alright, let's look at another situation. Let's take an angle, standard position angle of 300 degrees. So we're measuring from the positive x-axis, 90, 180, 270. I need 30 more degrees to get to 300. So the angle shown here is 300 degrees in standard position. The reference angle would be this angle between the terminal arm and the closest x-axis. And it would measure the remaining of the 360 from 300, which would be 60 degrees. One more example. Let's suppose I had a standard position angle of negative 30 degrees. So a negatively measured angle, we measure clockwise, which would be approximately there. There's negative 30. My reference angle is between the terminal arm and the x-axis. And I could think of it as being referenced back to quadrant 1 there. But it's a positive measure. So the reference angle would be positive 30 degrees. Alright, the reflecting of the reference angle back to quadrant 1, you'll maybe understand that a little bit better after we go through this question. The question says find 4 standard position angles that have a reference angle of 70 degrees. So what I'm going to do is I'm going to draw a 70 degree angle, which would be about so. Now that's a standard position angle, but it's also a reference angle because it's also the angle between the terminal arm and the closest x-axis. Now, if I were to reflect my terminal arm across the y-axis, my terminal arm would look like this. So here's my reference. My reference is still 70, but my standard position is measured from the positive x-axis. So my standard position angle would be 110, but it has a reference angle of 70, the angle between the terminal arm and the closest x-axis. If I were to reflect that terminal arm into quadrant 3, so if this little section was 70, then my standard position angle is going to be measured from the positive x-axis. My standard position angle would be 180 plus the 70, or 250 degrees. So all 3 of these angles have the same reference angle. And we can do this one more time to go to quadrant 4. I can reflect the terminal arm across the y-axis so that this little slice is 70, the reference angle, and so the standard position angle measured from here is 70 degrees short of 360. So if you subtract those, you get 290 degrees. All 4 of these angles have a reference angle of 70 degrees.